Hi everyone, I'm Fight, and today I want to talk about gt4llm, which is a little package that we developed to interact with LLMs. Before I start, I again have a little thing. I want to thank everyone for spending the last 4 days with me. I really enjoyed that, and spending the last 4 days with Smalltalk and together. It's always a ton of fun. So, with that out of the way, let's talk about something technical. We are going to talk about how we work with OpenAI and Ollama in GT. I'm going to show you the actual workbench that we're using to develop these things after we played with them a little bit. And then I'm going to show you one case study. Now, this talk has a lot less slides than the talk before. And that's because GT4 OpenAI comes with for LLM comes with two Leopard booklets, one for the OpenAI part and one for the Ollama part. We want to merge those at some point, but we haven't yet. Now I'm going to talk about the OpenAI part first, because it kind of informs on what we did on the Ollama side. I already showed you the Ollama side a little bit at Show Us Your Projects on Tuesday, but I'm going to just refresh that, and then we're going to go a little bit deeper, right? So the thing that we should probably start with is a client, right? The client is the basic building block. OpenAI is a online service, and it has an API that you can interact with. Now, you probably should set up your API key first, but I already have one in a file on my system, so I can just use that, right? And so when I generate a client, I get an object with a view. This shows me all of the different models that we have access to. Those are a few fine-tuned models that we have, and then all the standard models that you find on the system. Now I can go and query the client to list the models again, but this is the same thing that you see in the view, just a different object, right? So the view is kind of just a forward. And then we can also chat with the system already. So the way that OpenAI works is you send it, so the simplest endpoint is called the completions endpoint. You send it a couple of messages, and you say, write the next message for me in this thread of messages. So when we do that and we give it the system prompt that it's a helpful assistant, and then ask it how it's doing, it's going to remind me that it doesn't actually feel anything. So that's very, I don't know, Skynet, but it's very happy to help me, right? So that's kind of nice. But that's very low level in a way, right? Because that's not the kind of experience that you want to have. So the next thing that you do is you model the chat. And so we do the same thing, right? We have a chat here. I can ask it to help me find the lost key. I can do that programmatically, or I can use the little chat interface that we have here. This one isn't the best, but I'm going to show you the one that we actually use, and then it's going to be a lot better. There's actually something working in the background. You just don't see it. So it tells me how to find lost keys. So that's kind of nice. It's giving me kind of steps that I can take, right? But that's nice as a toy, but it doesn't give me anything yet. What I really want to be doing is I want it to answer questions that I care about, like about code or about domain models, that sort of thing. But it turns out that the standard OpenAI chat isn't really good at that. So first off, it doesn't really understand Smalltalk code very well. I suppose there wasn't a lot of it in the training set. And then it also is just very generic, right? And sometimes you just want answers, you want very terse answers and not the long rambling ones that it tends to come up with, unfortunately. So there are a few ways in which you can tweak a model. Now the first thing that we actually heard about in the LLM talk on Tuesday is RAG, Resource Augmented Generation. And what that means that we have to do is we have to generate embeddings. And I can do that with the client, or maybe not, because I have to create a client first. Then I can do it with the client. And then I get embeddings back from it. And then these embeddings are just, long vectors of floats. And what's kind of funny about this is that I can then do normal mathematical distance functions on those, and it's going to tell me which texts are related to each other. It's kind of magical, and that's why you use a model for it in the first place. So this is a trained model that does text embedding, but it does work. So I can look at how close different things are to each other. So in resource augmented generation, I might use this, for instance, if someone asks, what kind of class do I use if I want to model a file? And then it tries to figure out which part of your documentation matches that and pulls that part out. Now, that's well and good, but it requires a lot of machinery. So if you want to persist things, a lot of people use vector databases and that sort of thing. It also requires you to play around with how to chunk up your data, like what's the best size of input, that sort of thing, because you can put any amount of text into a vector and it's going to run similarity on that. So do I use each paragraph? Do I use a page of documentation? What do I use? That sort of thing. And personally, I'm not an AI person, so I don't want to deal with that. Now, another way that you can go is creating a fine-tuned model. So this is a model that you give a couple of example conversations between a user and the assistant, and it's going to learn from it how it should behave. So in this example, it's a very excited model, right? It's going to start every answer with something super over the top. You can do that. And then you put that in a file, right? That's JSON-L, which is each line is a JSON object. And then you compute the cost. So what would it cost me to train that? And in this case, nothing, because it's such a small amount of data that it's a fraction of a cent, right? And this is actually a moment where we can go back in time and talk a little bit about Python, because we use the tokenizer that we talked about earlier. So there, somewhere deep in there, we're actually calling Python code. And then we're getting back into our Pharo code to get the actual cost for things. But to count the tokens, which the amount of tokens is how much it will cost, we actually need to use Python. So that's kind of neat. Then we can actually take this and run with it and do fine-tuning. I'm not going to do that here just because the fine-tuning is going to run for a couple of minutes and I want to show you other things instead. You can play around with it if you have an API key. So this page is in the book, and this fine-tuning is almost completely free, which you can't say about a lot of things on the OpenAI API, but this is fun. We also have a page of how you would maybe do an example. Example data set. So we use all the examples that we have in the system and then use the views there to generate conversations and how they could look, right? So that's kind of useful. Now, another way that you can go, so this is the third way that you can go, is you can use what is called assistance. So assistance is a special API that in which you can give a system prompt to the model, and then you tell it, you're this assistant now, you have the following capabilities. So it can do code execution, it can be one of them. File retrieval can be one of them. So this is the resource augmentation part, but managed by them. It's a little bit more expensive than if you were doing it, but for prototyping may be useful. Yeah, that sort of thing. So you can actually interact with that tutor, that assistant. We call it a tutor internally, not the door one, but tutor with T. And yeah, So that kind of works pretty well. So this one is GT specific. It has a bunch of instructions that tells it to behave like a tutor that understands GT. It doesn't understand GT at all, but it pretends that it does. So that part works well. And then we can start sending messages to it. So we're also going to give it a file with all the views in the system at any given time, and then we're going to send messages to it, right? Now I'm going to tell it to write a snippet that divides 5 by 3, and that part it usually manages well. It knows that 5 divided by 3 is written as 5 divided by 3, so good job. And then we can ask it, okay, that's great. Can you give me a flow view on that? And that usually goes about as well as you would expect. It hallucinates most of the API, even though we tell it about the API, but it's not enough in the training set. So we're going to wait for it, and what's it going to do here? Oh, it actually does. This actually could almost work. So if we look at it live, we actually see the view. So good job. It does this about like 50-50, right? So 50% of the time it generates a valid view, 50% of the time it generates garbage. But the cool thing is that you can actually test it live. And this is not a method that's actually installed in the system, but this is just something that is a view that we build kind of ephemerally, right? And you can actually see the steps that it took. So this will lead me to the next point, kind of, but I'm going to diverge to llama for a second. But before we go there, just keep in mind that what I can do here is I can say, well, I know that I have to parse a small talk method and then execute it, right? So this is kind of the call graph. The green things are executed, the gray things are not executed, right? So this might not make too much sense yet, but I want you to keep that view in mind. Now, we're going to look at llama for a second, just to review, because llama has kind of the same capabilities, except way less capable. So the thing that we do to simulate this assistant or tutor is that we use model files. So model files are a way of taking a file, like a Docker file, and then telling it, a system message, giving it some example messages, and trying to teach it that way how we want it to behave. And so we have a tutor here as well. It's usually not quite as good, so I'm going to try write me a snippet that divides 5 by 3, but I'm not going to try even with the view, just because time is precious at this point already, and it won't generate anything useful, which is a little sad because this is the open source solution, but it's a little bit behind. So interesting. It's gonna divide me 5 by 3, and then it's also gonna do something here that I don't quite understand. I don't quite understand where it took that syntax from. I guess it just decided that looks good. Now, let's look at some actual case studies. So it's well and good that we can generate some code, but it's not actually good enough yet to generate us views. So what is it good for? Well, so the first thing that we did was we looked whether we could maybe do some business modeling with it. And I think Andre looked at that as well. Actually, let's look at this one. So we have a prompt here, and then we can build a context, right? Which, what that is, I'm going to show you in a second, but just bear in mind I need a context and a prompt. Then I can create this assistant with the context and the prompt. I also tell it not to bother creating any files. I'm going to add a chat, and then I'm going to chat with it. And as you can see, there's already an empty Wordly map here. So that's kind of exciting. And I'm going to ask it to please provide me with the nodes, positions, and connections for a Wordly map on on a drone delivery service, because that is a fun example I decided. Now, in the prompt, we give it a format that it should take. So it should highlight the nodes in some JSON. It should highlight the positions in some JSON, and then the connections, right? And it knows this, and hopefully it's going to adhere to it and create those. So in the meanwhile, Wordly maps are basically a two-dimensional way of thinking about business problems. You have nodes, you have connections. It's a very nice way of graphing things. Now, it told me what everything is, but then at the end, it also gave me the actual nodes and positions, and did not adhere to my, oh yeah, Dame. Very interesting here. So instead of name, it put Dame in one of the, okay. So all of them are gonna probably fail a little bit, but the ones that are early enough, they still work. So I'm just gonna show you, okay, all right. We're just gonna pretend that it worked, right? All right. What I think is interesting here is this still fails, and it fails relatively often. And I've developed a hypothesis why, and I have a better way of doing it. So it's good that it failed. But before we look at why these things fail, I still have this context thing that we haven't talked about, right? And and no one knows how the Wordly map got here. So we should talk about that for a second, right? So what an execution pipeline is, basically, is a simple way of composing steps on the last message that the assistant sent. So here, the default pipeline looks like this. You have three alternatives. The first one is, if it's for a Smalltalk code block, then we do the Smalltalk parser and the Smalltalk executor. And those are steps that we wrote. So we can look at this step and then look at what it actually does, right? But this is what it looks like, right? And then you have a Python parser if it's Python. And when it's a Smalltalk method, you actually have the method parser. And if it has a GTView pragma, we're going to do one thing. And if it doesn't, then we're going to do another thing. So this is maybe a little bit primitive, but it is powerful enough to explain a lot of different pipelines for what you want to do with these code blocks. And it's good enough that when I create a pipeline and I ask it to give me some Python, it works. And to verify that this actually is Python, because that could have been just as well Smalltalk code, right? Because it's just arithmetic, who cares? It actually does Python things as well. So, it kind of works. It's good. Now, how do we combine all of this into something that actually does a good job at doing what we want? And as always, the answer is make the things that it can do as small and as well-defined and as exemplified as possible. So instead of talking via the chat interface, I'm going to talk in terms of actions. Now, these actions are going to generate messages, just as everything else, but it's going to work a little bit differently. So we're going to still do the drone delivery service thing, just because I want to see how much difference it makes to show it like this, right? And you have a little thing up here that tells us there's something happening here. And if I look at the messages view here, I actually see that I'm giving it a map. If I look at the text, it's maybe a little bit easier. I'm telling it what is the action that I want to take, and then I give it the state of the current system. And then the map was empty, so I can render that. And it gave me a map back. That map looks much better than the other one. It knows which action it took. So it told me what action it took. It told me what the topic of the map should be, so that's good. And it gave me a Wordly map. So let's look at that Wordly map, right? Okay, so whether that's a correct Wordly map or not, probably it's just as terrible in terms of business knowledge as the one before, but it's actually a correct map. It looks like something I can start off with, right? Now, what I can also then do is actions on the individual things. I can tell it to add me a new connected node, and I can start interactively working with this thing. Now, what's maybe a little bit weird is this whole proposition thing here that's happening with the green. But basically, this is a way for me to first here look at the differences. So the actions that it took from here to here, all these nodes and these edges got added. And then to my message, there is no difference because we accepted all the propositions. And then the answer that just came in added this one node. Now I can look at it here, and I can decide I want this or I don't want this. And that was very important for us to say, I don't just want to take whatever it gives me, I also want to be able to say, no, this is actually not really sensible. Now, I can also let it explain me this node, but I could also ask it to review the current state. So like, you just created this, but tell me what's wrong with it anyway, you know? And it will happily do that, and it will tell that its own work wasn't all that great. So I think that's a very honest, upstanding citizen right there. Now, this is kind of, why does this perform so much better? And it is just because the prompting for me is much easier when I think in small steps, and because the actions are much more well-defined. So individual actions and state transitions are well-defined. And so this is much better than just asking it to generate me something big and then do whatever it tells me to do. So an action looks like this. It has a pragma. It has a name, a priority, that's where it shows up. It has a description, a format, and then some examples. And those examples are actually important in like tuning it to what you do with it. And then I also have format components. So those are things that are in the state. So what I send it and what it gives me back. So I tell it, this is what that looks like. Our messages should look like this, right? So that works really well, actually. And to show you how well that works, I'm going to show you something that I've done like 2 days ago, and it's probably, well, whether it works or not, we're going to see. But I dared to venture into Coder and actually add it to Coder and suggest me renames there, right? I'm just giving it the method and telling it, okay, now tell me some better names, right? I figured that was a small enough thing that I could give to the LLM. And indeed, you know, all of these, they're not terrible, they're not great, but it's much better, and it at least didn't generate any invalid code. So with that sort of guided approach, we're getting much closer to actually having a assistant that helps us figure things out. And now if I accept this, by the way, I get a refactoring, not just, you know, an acceptance. So it kind of works like the rename action that you can take in Coder, just guide it with an LLM. So maybe one day, if the LLMs get good enough and maybe fast enough, this might be in the default rename action. We're going to see. All right, that's all I have, I think. Thank you. Do you have any questions?
Any question?
Did you try several open source models like Llama, Mistral?
So the ones that we tried, if I remember them right from the top of my head, were Llama, Qwen 2, which is from Alibaba. It's very new. It beats all the others at the moment on Hugging Face. It seems to do really well. We tried Mixtral. We tried CodeLlama. They were all in varying states of unacceptable, but not terrible, but not quite what you want to have as a default anywhere. And the OpenAI ones are actually also very mixed. So GPT-4, which is what we're using by default, is great. GPT-3.5 was great. GPT-4.0 awful at following instructions, actually, which is surprising because it was announced and as the new thing, and it's very fast, but it's terrible at following your instructions. So if I tell it to all our messages should have this format, the first message is going to break the format 100% of the time. It's amazing.
Is it faster than 3.5?
That I do not know. It's faster than 4, that for sure. I don't know whether it's faster than 3.5. Possible.
And it was in small talk, but did you try in Python maybe? Or some equivalent?
Oh yeah, Python code is much better. Python code generation is much better. Now, view generation in Python is still a mixed bag because there's not a lot of training data, probably none. Yeah.
What other small actions do you
Wait for the mic. Yes,
Okay.
we need to record in the mic.
Okay. Excuse me. What other small actions do you foresee, like renaming the one you've shown, that you can try in the future?
Yeah, so we have a few things in Coder, right? A few actions. So like create accessors is too trivial, but there are some things in here, like extracting into a method, that sort of thing, where you actually have to input a little bit of stuff, where it might be able to help you. Now, what exactly it will all be able to do, I think it could help also critique your code. I wouldn't let it write your code, but critique your code and tell you, this API seems like it's not the best idea, and then you can ignore it and do it anyway. I think that would be quite interesting. Thank you.